There's a saying in the Kannada language, madve maadi nodu, mane katti nodu anta. That means you need to have a organizing for a marriage, and then you need to build a house to gain experience. That is what it is. And to build a house, it is so tough. And of course, it takes a lot of time, and it takes a lot of investment of money, and it takes a lot of doing and oneself of investment into it with love and care. That's how a building is coming up. And that's the same love, care, and investment that I have invested to catch hold of Dr. Nakul Ramana. It is easy to build a house, but it's not easy to catch hold of him because he is so busy and he is doing all this for the students. Now that is what is so important. Dr. Nakul Ramana ಅವರೇ, I'm so happy that first of all ನೀವು ನಮ್ಮ ಕನ್ನಡಿಗರು ಅಂತ ಹೇಳಿ. And ಎಷ್ಟು ವರ್ಷ ಆಯಿತು ಪ್ರೆಸಿಡೆನ್ಸಿಗೆ ಬಂದು ನೀವು? How many years?
ಸರ್ ಪ್ರೆಸಿಡೆನ್ಸಿಗೆ ಬಂದು 3.5 years ಆಯಿತು.
Lovely. And under Sri Anadini, you were another program chair under him. Is that how it is?
Correct, sir. I was joined as an associate professor, and Anadini sir had joined as head of the department. Right. So we worked under him.
Fantastic. So he is handling the civil department in Presidency University. He is making sure the future engineers build a proper road, build proper flyovers, build proper buildings. So fantastic. But ನೀವು ಎಲ್ಲಿ ನಿಮ್ಮ ಸಿಮೆಂಟ್ಗೂ ಮಣ್ಣಿಗೂ ಕಲ್ಲಿಗೂ ಪ್ರೇಮ ಹುಟ್ಕೊಂಡಿದೆ ಅಲ್ಲಿ ನಿಮಗೆ?
It started off with B. When I started civil engineering. So basically based on my back then CET scores, I was qualified to do mechanical engineering or civil only. So my dad was recommending take civil because it's more hands-on. And so that's how it started. I said, let me see at least 2 semesters. If I don't like civil engineering, I'll take branch change to mechanical. But I liked the field. Fortunately, our faculties were very good. So then it started on. After that, finishing BTech in Ramaya, I did my MTech also there. And we were affiliated to VTU. We are the first batch of VTU students in BTech. Started in 98, correct. Okay. And after my MTech, I went on to do PhD at Old Dominion University. And that's when I decided to be a researcher and then come back and teach students. Wanted to be in the academia more than the industry.
I know, really. And how nice it feels. From Ramaya, you're the first batch to kind of pass out from there. And VTU and all that. So in VTU, your name is put on the wall.
I hope somewhere it is there. 164 students had joined back then, but only 38 graduated 4 years later from civil in Ramaya. So programs were intense.
Yes, that's why you are here, taking care of the intense subjects. But talking about Presidency University, of course, we know the campus is marvelous and fantastic. And on those lines, how much do you feel like when you entered? What did your engineering brain actually say? Civil engineering brain actually say about the design of the Presidency University campus? Because I keep asking generally everybody. They say it's fantastic, it's marvelous, green, lush. Because see, that is how a normal man will think. But as a civil engineer's brain will think something else. Correct. So what was your brain thinking when you saw this campus?
It was very nice, structurally very sound. Architecturally, it was well planned also, because we rarely get to see the kind of Kirby steel canopy that you see here. And it was very pleasantly done. A lot of birds still on campus. That's nice. And engineering D block and E block were already in existence when I came here, but the new engineering blocks were getting built. Okay. So one thing I felt was they could have engaged our own civil engineering faculty also to do the QA/QC work or also structural engineering. That's what I felt. Back in Ramaya, that was a protocol. Anything that was being built, first of all, faculty had to be engaged in it. Only faculty or students could not do. We would go for external. But here I think from the construction point of view and how quickly they wanted the project to be done and turned over, so they went to the industry people first to deliver. So I said, okay, so our faculty and students missed out on that experience because they could see their own designs being implemented here, built, and they would realize that they are part of the project. So that one thing I felt was missing. And interestingly, some of the labs that we see here are on first floor. Usually you see all civil engineering labs, they are heavy duty, so they would usually be on the ground floor. So the nature of construction is very good. All we had to do for heavy equipment was just install the vibratory pad, and it would not make any sound or disturbance on the base floor. So the thickness of the slabs are very nice.
Actually, no, the cement.
This is a good observation.
Lovely. No, this is what I wanted, because this wouldn't have come from anybody else. It can come only from the great civil engineer in our Presidency University. Fantastic. And talking about labs, so how many labs do we actually offer to students who come into civil engineering? How many labs does civil engineering department own actually?
Civil engineering departments has 5 labs, and we give students about 11 labs in BTech and MTech combined. Just in BTech, we have about 8 labs that we give to students. Yes.
And so we'll be also touring those labs. And the first lab, what are we getting into? Which is the lab that we are entering?
First lab is the Geotechnical Engineering Lab, also called as the Soil Mechanics Laboratory. This is very good for undergraduate instruction, consultancy, research. So all of the equipments are state of the art. We do have direct shear test, consolidation apparatus. We also have our standard Proctor test that is very typically used in all highway constructions. So an interesting point is we let students operate all these things, and some of the equipment we are going to be digitizing. So the test process is automated, and also there is more accuracy in the readout. All of our equipments are serviced and calibrated once a year.
Oh, lovely.
Yes.
Lovely. And also when it comes to civil engineering, what happens the start of it, like the planning stage? I'm trying, because today if we are trying to build a house, it's not about foundation anymore. Now it is all on pillars. So because what used to happen back then, we used to just have a piece of paper, and the person who wants to build a house, probably your father, my father would have done the same thing. Just put it out one square on the paper and dig it in between, and then every foundation is ready and build up the wall. But where is the planning stage coming in? So do we teach it from the planning stage to our engineers?
Yes. We start off with elementary courses. Back when I joined, we had elements of civil engineering. So now we do elements of engineering mechanics to the students as per the new curriculum. Then we introduce them to engineering geology, strength of materials, building materials and concrete technology. So now students are not only aware of the concepts in civil engineering, but the basic materials that are used for construction. Then we have a lab course called building planning and architecture. So where they learn about different elements of civil engineering and how they look like when they're put together. So after that part comes the analysis. So we have computer-aided structural analysis lab to help them with analysis. Then we start them off with design of RCC, PSC, precessed concrete structures, steel structures, and then we also teach them with design. So we teach them in the course, theory courses, where they do hand-on calculation using the code books. In the labs, we teach them how to do the same thing with sophisticated softwares. So we have ETAP software to help us in that process, STAT Pro for structural analysis and design. For drafting and detailing purposes, we have AutoCAD, and then we also have Revit architecture. And then for construction management purposes, we introduce students to Microsoft Project and also Primavera. So we also teach value-added courses in case students miss some of these courses because of the way they choose the curriculum, which is fully flexible now. So we do offer value-added course in Primavera, construction management, cost estimation also we do, and building information modeling using Revit. So students get to take all these courses at their own spare time. And value-added courses, the beauty about it is it's online. So students get a hands-on experience, and we give them the software, 1-year license, so they get to practice on their own in their home at their convenience. So
fantastic.
And support so much.
Superb. So I see a lot of equipments. Yeah. So how are we going to start off from here? So before going this, going to this, one very important question, and a kind of a tough one probably, because everybody watching will want to know this: brick or solid block? What do you suggest?
These days, everything is portal frame. Concrete takes all of the load. So people tend to go with block. You go with hollow block. Okay, both are good, because hollow, when you have a beautiful structure like a portal frame, concrete beams and columns taking the load, you don't need to go with solid blocks. That increases the dead load, increases your foundation footprint. Instead, you can go with hollow block. It just serves as partition wall, plus it also gives you some lateral stability. And if you want to save on floor space, then you can go with bricks. So there's no harm in that.
Right. So both are
elements are always the beams and the columns and the slabs. Okay.
So you give equal weightage to both bricks and solid blocks both.
Yes.
Okay. Fantastic.
Blocks are stronger and more denser. But hollow blocks and bricks are preferred first.
Actually.
Less cement. So and cement is
which is more durable and strong.
Concrete. So cement based products are more strong, long lasting. Bricks are only good if you have plastered them. So there again, you're using cement for covering it, unless it's a fire clay brick.
Fantastic. And I have another tough question. We will talk about that after talking about the equipments. What is this, Nakula? So what is this apparatus called for? Why is this used? What is all this?
So this is a triaxial test apparatus. So we can apply load on the soil from 3 different directions and study the performance. So this is very good for foundation design and highway pavement design. So you need parameters from here and CBR test to efficiently design a long-lasting, durable pavements.
Right. So these are the same equipments on one row, and we see another set of equipments here as well.
This should be the consolidation apparatus. Basically, whenever your soil gets exposed to moisture, different types of soil, and on increased loading, how they are going to be compressing is what we are going to be studying in here. So basically, this helps us identify optimum amount of load that you can apply for any given kind of soil without compressing, without foundation settlement. Because you could build a beautiful framed structure, but if foundation is settling, cracks will start from there. That's a bad thing to have. Okay, so strong foundations you have to do consolidation test.
So how much of like the people believe this, because solid structure comes out of proper curing,
Correct.
right? So how much of importance do you give, weightage do you give to curing?
Curing is very, very important. We teach our students you should always take care of 3 C's. One is the compaction. The second one is the cover. Ensure that before compaction, the proper cover is there for the reinforcement so it doesn't corrode. Then follows the curing. Because once the structure is done, it's important to cure. Typically, before loading the structure, they say 28 days of curing is important. The first 3 days of that is very, very important. After that, even if the structure is intermittently wet, it will go on and still give you a better structure. But the first 3 days, there is a lot of heat of hydration and internal cracks could be formed. Shrinkage cracks can happen. So the first 3 days, you have to keep your structure moist cured.
Totally wet, totally moist then. Yes. Fantastic. So after this lab, we have an adjacent lab also where we have the survey equipments, so that is really important. So do we consider the survey equipments to be the kind of costliest ones in our civil department, or is there anything more costlier than these ones?
Yeah, we do have some equipment in basic material testing lab and concrete lab that are more expensive. So in our survey lab, we do have a lot of equipments where we teach students how to do conventional, traditional surveying. So we have plane table, we have our ranging rods, tripods, all that is there. We also have compass. So this is the tools that we basically use to take our students on extensive survey project, teach them the old traditional methods, so that when we go on to do the current ones, which is electronic theodolite and total stations, so they appreciate the effort and how much technology has made it easy for them, and they don't take these things for granted, because one of these days these equipments breaks. That's what they have to do. That's what our our former civil engineers basically did. So
Lovely. So on these lines, I have another doubt. Like, probably it might sound a little funny, but pardon me for that. But I've seen people now ಚಿಕ್ಕ ವಯಸ್ಸಲ್ಲಿ ಹಿಂಗೆ ಟೈರ್ ನ ಸುತ್ತಕೊಂಡು ಹೋಗ್ಬೇಕಾರೆ ಒಂದು equipment ಇರುತ್ತೆ. We have that kind of an equipment. Yeah. Yes. What is that actually?
That's basically for measuring the length.
Okay.
So typically to measure the length, you need something like a tape. One end has to be anchored or stuck somewhere else where you pull it to the other side and do the measurement. So sometimes it's a 2-person job. But when the road profile is contoured, while you're trying to measure, that tape can get sucked into the roll. So usually they have something like this, which is like a wheel that is calibrated. So one rotation of the wheel equals to certain length. So they calculate the number of rotations. From that they get the distance.
Nice. So
You have to take care you're walking straight with the wheel. That's all.
You have to be as sober as possible.
Yes. If not, you'll get some excess length in there.
Lovely. But on these lines, what is more interesting to our students? Like if you are a engineering student yourself, what would more excite a student who's taking it up for the first time? What is more exciting about it? Is it the structure, design, or is it something, building something which is not existent?
Building something more that is not existent. How to put all these things that he has learned together to make a structure where somebody will live or somebody will walk on. That is, I think, the most interesting thing. And we are also going to be upgrading our equipments further. We are in the process of procuring drone. So for drone-based surveying, photogrammetry, so we can survey a bigger area quicker, able to do contour surveying easily and plot the area profile. So we're in the process. That helps also with consulting, and that is the trend. So if you go outside these days, a lot of drone-based surveying is happening, even for remote sensing and GIS works. It's helpful. So we're trying to equip our students with cutting-edge skills.
Fantastic. And that now brings me to that my second tough question. Why is Nama Metro getting so delayed?
Probably contracting.
Actually.
Yes, and
but on the building perspective, why is it taking so much time? I mean, is it for the blocks to be put up there? Is it tough for the engineers to maintain on those lines?
It's probably land acquisition costs. Yes. and then the pace of construction, you need so many workers to be on duty all the time. So I think there the coordination is lacking, and a lot of contractors are also there. So that's why we need a professional software or expertise there for construction management. See, this is what we lack. We usually get only structural engineers or architects. Everybody does their components, but interfacing all these contractors and the elements together where there is no clashes, and predicting the scheduling for the next 3 months, 6 months, doing inventory control, that requires a special area of expertise.
And
It's called
that is what-
construction management. So people have to emphasize on that also.
And that is what we teach our students here.
Correct. Yes. So we offer electives in construction management also, and Primavera and MS project is taught to our students as discipline electives, and it's also there as a value-added course. Plus, we have a master's called Building Construction Technology. So that is where 75% construction management and 25% structural engineering-based courses also we offer. So students get this wholesome background experience on how to soundly run a project. Yeah.
And-
Now,
and
this is the
efficiently.
technical point of view. Correct. Efficiently. That's true.
So we'll move down to the next lab, which is downstairs.
Correct. It's called Basic Material Testing Lab, and we can go there.
So strength of materials lab is what we are getting into now, and we have Dr. Nakul Ramana also along with us. What is this lab going to do to us and to the students?
Okay, this is called Strength of Materials Lab, also referred to as Basic Material Testing Lab. Usually students take this lab in their 3rd or 4th semesters to understand about the basic properties of certain materials and the strength.
Oh, lovely. Okay, so this lab is where we have the most heavy equipments, most costly equipments.
Correct, that's right.
Okay. So what are all these equipments, namely? And we there we go. That is the raw construction materials that we always find.
Correct. That's commonly referred to as jelly,
Yes.
coarse aggregate, and fine aggregate, which is sand.
Right.
So we teach our students how to work with the river sand as well as M sand, because now river sand is not
Yeah.
available all the time. So we have to go with M
this
sand.
this was my third very tough question.
Okay.
The natural sand or M sand?
M sand. Okay. Yes.
Just
You
because of
can
the industry
produce-
needs, or
No. You can produce it with consistent quality. The problem with some of the natural sand is the source from where they are got. It could be beach sand, etc. A lot of chlorides and sulfates might already be in there. So when you introduce that to concrete, your structure will start to deteriorate faster because of corrosion. So you hear, at least with granite, they don't have so much chlorides and sulfates in there. They're free from all these alkalis. So that way, you're not introducing any harmful ingredients into concrete. Plus, when you're crushing the rock, you're doing it with a machine, so the quality will be consistent. So you can expect zone 2 or zone 3 grade for a big pile of M sand. So even when you're sampling many times, you will get consistent quality. You also get something called as P sand, which is the plastering sand. Very fine sand of M sand is P sand they use for plastering. M sand is a typical coarse sand they use. There's also some disadvantage with M sand. For example, it absorbs a lot of water because of the dust particles in there. Water absorption of your fine aggregate natural river sand is probably about 0.5 to 1%, maybe 1.5% max. But this M sand can be anywhere from 4 to 8%. So whenever you're doing your concrete mix design, you also have to account for the water absorption capacity of your M sand. If not, it tends to be more stiffer because it tends to steal now water from the concrete, and in the process it won't be so much workable, and you will have to use more chemical admixture to make concrete workable or flowable. But if you calculate your water cement ratio before in advance and also include the water absorption capacity of M sand, it will be just like your river sand. You won't notice any difference. Okay.
So all these big trucks that they keep rolling with big concrete, so now they'll have to really make sure that if the M sand is used, the ratio is really perfectly done and mixed.
They take care of it. RMCs do take care of it. So the other contractors, they may not. So we have to always educate them in this regard, or they tend to discourage the client, saying it makes the mix stiffer. This big area of slab cannot be poured. So we'll go for
Normal
river sand, etc.
So much knowledge, really, for people, not just students, for normal people also watching our channel, it gives so much knowledge, because everybody doesn't know this. And talking about the concretes, our students also created something without cement, is what I heard. What is this?
Yes. Students have made geopolymer concrete beams in our university, and we also have a PhD research scholar, Prithviraj, working under Dr. Anadini sir. His research is also on reinforced geopolymer concrete beams. This was actually a BTech project in here. Students did 3 beams of varying steel, And this is the three geopolymer concrete beams that they have done. It uses no cement. It uses waste material like fly ash and GGBS. Fly ash 45% and GGBS, ground granulated blast furnace slag 55%. And no water is used in here. You have used sodium silicate and sodium hydroxide solution. So those are your alkali activators that binds your geopolymer material together and causes geopolymerization reaction. So it sees and feels like regular concrete, except that you're just working with waste materials. So that's why we are doing strength and durability tests of GPC here at our Presidency University, and we were able to get strengths up to M80. Newton per mm square. Just to give you a quick comparison, most foundations and slabs, they are all M40, 45 grade. The bridge decks that you use in Nama Metro flyovers are all in M60 grade. So here we have been able to easily produce up to M80 grade concrete.
Anybody watching from Nama Metro, you can hire students from our Presidency University and use a lot of geopolymer stuffs going on. So we are entering another lab which is kind of looking very huge and please explain what is this now.
So basically we are in the strong room, a room within a room. Here is where we house the most expensive equipment we have here. It's called Universal Testing Machine. Just as the name suggests, we can do tension test, compression test, bending test in here. And also we do shear test of metal fasteners. So a lot of tests that can be done in here. Currently we are doing in-house quality testing for all the steel rebars that they're basically using in our own university for construction. So we're doing physical tests as well as chemical tests in the lab.
Fantastic. So we'll also go through this space as well. And talking about the geopolymer cements, how much of it is in regular market practice now, Dr. Nakul?
See, geopolymer cement is still not readily accepted by the industry. Main reason is how long can you keep the concrete workable, and the requirement of admixtures. You cannot pre-mix it; has to be done 24 hours in advance, and so all these drawbacks are there. So it's still not reached a scalable stage where you can actually use it in the industry. But there is a company called Bana Cement in UK that has actually made it a little more easy. They have added all the chemical additives and made a cement with geopolymer based cement. All the admixtures are in, you just have to add water, that's it. So the technology is coming forward so that industry embraces this cement. Probably in the next 5 to 10 years you will see many of the structures being where geopolymer concrete is becoming the standard construction.
Thanks for that company who's given us the ready idli and dosa batter, like concrete, which is always ready. So this is really nice to know, and we hope that geopolymer comes into existence very quickly. So how far ahead our students are getting prepared for that?
We teach our students how to do green building materials also. So as part of sustainable materials and green buildings, they learn about alternative building materials, LEED rating of the buildings, etc. And in their final year project, we also ask them to do some kind of structural blocks, basically out of green cements, basically where they're replacing cement with alternative cementitious materials, trying to experiment with it, try to find a replacement for your coarse aggregate, how to use more industrial waste and still make sustainable, durable concrete. So they try to engage in that. Plus, from the third semester itself, we train our students, on the basic properties that are required for construction and how to not compromise on that. So just behind you have a hardness tester. Basically, we use this for metals to check the consistency batch after batch if it's meeting certain criteria. And this is our impact testing machine. So any structure that we build can not only be subjected to static load but also sudden impact loads. So how will the structures fare in those conditions can also be studied by running a small sample in this impact testing machine also.
Super. So we'll just come inside this and anything on the lines of saying how the material is so good to be taken in also depends on the budgeting, isn't it?
Correct. You can go with the most expensive material, which is very strong, but may not be feasible to be built. So that's why we don't use titanium everywhere.
Actually.
Correct. So based on the budget and availability of the material, the strongest and the most durable that we can afford is always game that we need to chase. So these materials, test equipments, will help us identifying the right material for the right project.
I have another doubt here, because as a student, even I'm kind of learning a lot of civil stuffs from the man from our university. But you know what? These white toppings that we used and which caused a lot of jams in our traffic as well. On those roads, can geopolymer work well?
Yes, geopolymer concrete can definitely work well there also. Initial curing has to be taken care of, and during mixing and placing stage, if you take care of the precautions, then I think that will be a long-lasting concrete. Plus, even if you're going to be using conventional concrete, we recommend at least you use 30% or 40% fly ash in there, so that you're trying to save on the cement, and that reduces the cost of the project also.
Lovely.
Yeah.
So what all doubts I am asking, actually it is in the syllabus in our civil engineering department of Presidency University, and I'm making sure that people watching get to know about it. What are we actually trying to tell and everything? So it says this equipment looks really compact, but I'm sure it does a lot of work.
Yes, this is the compression testing machine, and so any kind of concrete block or cylinder can actually be tested in here. If a cylinder can be tested in compression as well as tension, because concrete can be subjected to both compression and tension. Where it's weak in tension, we put steel reinforcement. So that's an important property we try to assess, and how strong you're able to make your concrete. We have to test it by compression, so we do usually cubes here. So all that get tested in here. So in this lab, we have a analog machine, so that gives us the data using a dial gauge, and in our concrete lab we actually have a high performance, a higher capacity digital testing machine, so that gives you more accuracy also. That's just turn it on and forget. So it and it shuts it off after testing.
Superb.
We
So
have the old kind. So for students, because depending on which labs they go to, where they have access to QA QC files, they should know how to operate both. Correct.
very true. And you know, talking about students and also about your experiences also, wherein if at all, what do you, because engineering or rather especially civil engineers should not compromise on anything is what we are trying to say.
Correct.
Tell me how to wave away those relatives who come and say, Nakul, please draw me a plan and give me. Nakul, please help me construct my house. Nakul, do this, do that. How do you put them away?
Quality comes at a price, right?
There you go.
They should give you the time to do it. But the problem so happens that I've already asked my contractor to dig, so you just give me a plan that gets approved. I tell him, like, it won't fit. You have to get the plan first, ensure that the plan is something that you really like, then go for construction. In between, you start changing plans because you want the room to be bigger, or because of vastu consideration, you're trying to change the dimensions. We would not have accounted for that use in the structural calculations. So span of the beam, how much load it can take is also something is very serious. You suddenly change the orientation, location of a column, or increase the room width, then we'll have to think about the other loads that can come on the structure and can cause cracks.
Okay. No, another important. Again, a difficult question. It's striking my mind. Do you feel Vastu should be incorporated in civil engineering?
Yes, we teach that to our students also.
Already? My God, are you serious?
Yes, because that's what the market demands. And for architectures, they do learn a course. So in our university, we offer a value-added course for students where they learn about basics of Vastu, and we try to incorporate that, and we also ask them how to do that in AutoCAD also. So that all these elements are basically considered, including where the fresh water intake has to be done, where the wastewater exit has to go, which should be the biggest room, where should be the puja room, what should be the dimension of kitchens, and number of doors to windows ratio.
No, you know
Which
what?
direction it can be best for light perspective.
Correct.
If not, what can be done early on in the construction stages, so that way your customers are happy.
And even the number of steps have been, something like Shubha Labha.
Correct.
Something like that, no? So guys,
The rise and tread of the steps is also calculated based on that, because you need certain number of steps to reach a certain height. So students can calculate based on that
my
now.
God, guys. So Presidency University offers everything in civil engineering, right from Vastu to even somewhere even Grow Pravesha mantras. No, I'm just joking.
Think of that.
We should think of that actually. No. But it's really nice to incorporate Vastu because it is such a big need now. Okay, say for example.
Makes you more employable as a student if you're familiar with this, because that way you, for small scale projects, you're easily able to replace an architect, and your clients will also be very happy.
Actually,
Yeah.
no, it's more of concluding on this talks. It is really lovely. But before I even ask, do you believe in Vastu? What I feel is it is science. Basically where your light should come, where your air should come, and they've given that name as Vastu. Is what I feel. Is that right?
Correct. Once Vastu is the basically ancient science for scientific living. So I totally agree with you. So it's basically based on those principles of light, air, and energy. So, and how to maximize all of those so that you can stay comfortably in the home is what Vastu is about. So by learning Vastu, students are also learning about the right principles of building a house.
Perfect. No, the reason why I asked that is because it is not it is not attached to one particular community or language or anything. It is science. Vastu is basically science, and that's what we are teaching our students. Dr. Nakul Ramana, it is fantastic to have you and to catch hold of you for such a long time. Was my Vastu, my this one. But no, I was just joking. But you do such good work for the students. It is fantastic because I personally have heard from your students that you always make them feel so comfortable in their classes. Fantastic. Please keep up the
Kind words. Thank you, sir.
and please keep doing the same works. And for students who are seeing it, one call from the man itself to come and join in this fantastic course of building lives and building people's dreams.
Yes, true. With quality. And durability.
And durability.
Yes, yes. Thank you.
So thank you so much for your time. And now we will go learn more of Vastu from him. And I got to get my plan done. So I will not leave him. So
Can also assist you.
there we go. The project is already ready. Thank you so much.
Thank you, sir. Thank you.